Hey, good evening, guys. Give you a few notes here for our transformation starting this unit. I'm going to show you here what your parent function should look like that you should have done in class today. Here, the first one should have looked like that. That's a quadratic. The second one here is a square root. Then we have a cubic. The fourth one there, that's an absolute value. It looks like a V shape. The first one, or the fifth one here, that's a rational. The next one is exponential growth. And one thing that's important about exponential growth is the 2 here technically is not, it's not always a 2. That 2, it could be a 3, it could be a 4, it could be a 5. The important thing is that this number is greater than 1. That means you have exponential growth. As opposed to the next one down here, which is exponential decay. If you'll notice that we just flipped it and made it a 1/2. 1/2 is not significant there. It could be anything less than 1. It could be 1/2, 1/3, 1/4, anything. But any number less than 1 is going to give me the decay. And then we have a ln of x. This is called the natural logarithm. It means it has a base of e. You can graph that on your calculator. It has an ln button. And then we have a log, which is log. That's a common logarithm. That means it has a base of 10. You can also graph that on your calculator because there is an log button. And then the 3 on the back that you were supposed to graph were the sine, cosine, and tangent. Probably what you saw on your paper, if you look back at your notes, was just this part. You probably just saw this part right here of your sine graph. But if we continue with that pattern all the way over here to -2 pi, we just get the same thing again. And the same thing for cosine. You probably only saw that part on your graph when you went back and looked in your notes, but if we just graph the whole thing, that's what we have there. And then that's, again, the tangent function. You probably only saw this part of the tangent function when you looked in your notes, but I just graphed it all the way out from -2 pi to +2 pi. Okay, so on the sheet that I gave you today, what I want to focus on is the transformations here. So we're going to look at this table here, and then I'm going to give you a few examples of the transformation. So if we're looking at our chart here and we want to describe the transformation, f of x just means the function. So any of those functions that I just showed you, any of those parent functions could represent f of x. It could be a quadratic, a cubic, an absolute value, a square root, a sine or cosine, any of those. The b is just representing a number. Okay, any number, any rational number that we can use. So if I have the function plus b, which means b is outside of the function, what that means is I'm going to actually move the function up. Okay, so if I add b here, that's going to move the function up. Okay, and how far up? Well, it depends on b. If b is 5, it'd move it up 5. If b is 2, it'd move it up 2. Okay, so up b units is essentially what it's going to do. And what does that mean as far as your coordinates go? Well, that just means that you are going to simply add b to all the y values. Okay, so you're going to add b to all your y values if you have plus b. And again, if I have minus b, then that's going to move the function down, which means I'm going to subtract b to all y values. Okay, and so that's going to take the function basically and move it up or down. Now notice with the next one we have f of x plus b. We've moved the b inside with the function. So what this would look like is it would either be underneath the square root, it would be inside the x if you had like a quadratic problem, or it'd be inside the absolute value. And again, we have a plus or minus here. Now what happens here is it actually moves the graph opposite of what you think. So if it says plus b, we're actually going to move the graph to the left, and minus b, we're actually going to move the graph to the right. Okay, so if we're moving it left, that means we're subtracting, because on a number line when we go to the left, that's minus. Okay, that's negative numbers. So we're going to subtract b from all the x values, because now we're going left and right. And if I was moving to the right, I would add b to all x values. All right? And then here, the next one, we have a negative out in front. What that means is that we're going to reflect over the x-axis. Okay, and when you're reflecting something over the x-axis, what happens is you actually change the sign of all the y values. It's kind of opposite maybe of what you'd think there. When you reflect over x, you're actually changing the sign of y's. But notice what happens when that negative is inside with the function. We're going to reflect over the y-axis, which means I'm going to change the sign of all the x values. And by change the sign, I mean going from positive to negative or negative to positive. Okay. Sometimes this can get a little tricky. The way that I remember this is if there's a negative on the outside, you know, I say that it has exited out. Okay. You know, like exit out. All right. And if the negative is on the inside, I always look at why am I in here. Okay, so if it's inside, why am I in here? That reflects over the x-axis. If it's on the outside, it's exited out, reflects over the x-axis there. And why am I in here reflects over y-axis. And exit out reflects over x-axis. All right, so here we got one more. If I take and multiply the function by a number, that's what we call a vertical stretch. And what I'm going to do is I'm going to multiply the y values, okay, by whatever that number is. All right, so that is all the transformations that we're going to be looking at, and we're going to do these with all of our functions. So I can give you any function, and we should be able to write down these transformations. So let me just give you a few here, and then we'll do more of these in class tomorrow. So looking at this one, you have x minus 3 squared plus 5. Okay, you see the squared, so that means that its parent function is x squared, which means it's a quadratic. Okay. Now, here's the transformation though. All right, if we're looking at this, we're just kind of going to read it left to right. We've got a minus 3 inside with the x. So the minus 3 is inside of the squared. So what that means is we're going to move it left or right. And we're actually going to move it the opposite of what we would think here. So it says minus 3. So that means we're going to move this one to the right 3 units. And then the plus 5 is on the outside. So we're looking at this one right here, our very first one. So that means I'm going to move it up 5 units. And you just describe the transformation. Okay. Number 2, you look here, we have the absolute value symbol. So its parent function is the absolute value of x. That's an absolute value problem. All right. So take a look here. We've got a negative out in front. It's exited out in front, so that means we have a reflection over x. Okay. We've got a minus 3 on the inside, so that means I'm moving it to the right 3. And then we've got a plus 8 on the outside, so that means I'm moving it up 8. And that is my transformations for that problem there. Okay. Hopefully you're seeing how this works a little bit. Looking at the next one, we've got a cubed. So that means that's an x cubed problem or a cubic. Okay. Going left to right again, you'll notice here I have a negative in front of the x now. So that means the negative is inside. Why am I in here? So that's going to reflect over y. I've got this minus 4 here, and remember we're doing the opposite there. So that means I'm going to move it to the right 4. And then I've got a plus 2 on the outside, so that is up 2. Describe transformation. Okay? So hopefully you kind of got those down a little bit. I'll look at 4 through 9 tomorrow. We'll go over those at the beginning of class, and then I'll let you work some more transformations. So we'll see you guys in class in the morning.